Hello everyone, welcome back to my channel Math Smart Tips. Today in this video we are going to discuss about Bessel functions and their properties and their recurrence relation. So Bessel function is a very important topic for GATE exams, for mathematics section and also for engineering mathematics section. So in this video we are going to discuss about Bessel function, a gist idea about Bessel function. We are not going to very deep sections of this function, so just a gist idea about Bessel functions and their properties so that you can solve the problems related to Bessel functions and their properties. So before starting, I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. So first, let us write the differential equation x square d2y dx2 plus x dy dx plus x square minus n square to y. This is equal to 0. This equation is called the Bessel equation. This equation is called Bessel's equation. Now, to solve this differential equation, suppose let us give 1. So to solve this differential equation, we apply series solution method. So if we take the solution y equal to summation m equal to 0 to infinity cm and x power k plus m or c0 not equal to 0. So if we take this series solution, then now calculate y dash and y double dash, then putting in these equations, and after calculating the coefficients c1 c0 c1 c2 cn and so on, we get this type of solutions. So the solutions is of the type we get y equal to a x power n into the series 1 minus x square by 4 into 1 plus n plus x power 4 by 4 into 8 into 1 plus n into 2 plus n, this type of series and so on terms. And if we put another one, we get the solutions. This is equal to, we can also again write b into x power minus n and 1 minus x square to 1 plus n, 4 into 1 plus n plus x to the power 4 into minus n, 1 minus n. We replace n by minus n, then we get 4 into 8 into 1 minus n into 2 minus n and so on. These two are the solutions of this differential equation 1. Now by taking in particular a equal to 1 by to the power n gamma n plus 1, we get the Bessel function of first kind, which is denoted by Jnx. So Jnx is the Bessel function of first kind, and it is written as x power n by 2 power n gamma n plus 1 into this series, first series 1 minus x square by 4 into 1 plus n plus x power 4 into 4 into 8 to 1 plus n into 2 plus n and so on. This is the series. So in series format, that is in summation format, it is written as Jnx. This is equal to summation r equal to 0 to infinity minus 1 to the power r by r factorial gamma n plus r plus 1. This is gamma function over this, and x by 2 power n plus 2r. So this is the function Bessel function of first kind, which can be denoted as Jn x. This. Now, if we replace Jn by j minus n, then we get j of minus n over the function x. This is equal to summation r equal to 0 to infinity minus 1 power r by r factorial gamma of minus n plus r plus 1 x by 2 power a minus n plus 2r. So this is the j minus n x. Now this is the basic definition of Bessel function Jnx, and the equation one is called Bessel equation or Bessel differential equation. Before going to the recurrence relation, we are recall some properties about gamma function or beta function. Since the properties of this related to these two functions, these two are very important for the recurrence relations and the definitions of Bessel functions also, since here the gamma function are included. So beta, I mean, now we all know that gamma n, this is equal to, we can write integration 0 to infinity. We all know these properties, x power n minus 1 into dx, where n greater than 0, number 1, and the another form of gamma function is equal to 2 into integration 0 to infinity e power minus x square x power 2n minus 1 into dx. This, and the basics of these two are generally gamma 1 equal to 1, gamma half equal to, we all know that these properties are very important for integration also. And the properties of the definition of beta function is beta mn is equal to integration 0 to 1, you can write x to the power m minus 1 into 1 minus x to the power n minus 1 into dx. Also this is equal to, we can write integration over 0 to 1 x power n minus 1 to 1 minus x power m minus 1 into dx, where m and n both positive, and this is equal to beta nm. Therefore the definition of beta function shows that the beta function is symmetric type, and the relation between beta function and gamma function is given by, so beta mn, this is equal to gamma m gamma n by gamma m plus n. This is the main relation between beta function and gamma function. So these properties are very important. So let us come to the point, recurrence relation of beta function. We are not showing the proofs of this recurrence relation, we are just saying the recurrence relation. So now recurrence relation, since these recurrence relations are most important things of Bessel functions. So the first one is j of minus nx equal to minus 1 power n into jnx. So this is the relation between jnx and j minus 1 x minus nx. Relation number 2, this is j half x, this is equal to root over of 2 by pi x into sin x. This relation number 3, j of minus half x, this is equal to root over of 2 by pi x into cos x. Relation number 4, j half x square plus j minus half x square. This is equal to sin square x plus cos square x. This 2 by pi x square means 2 by pi x plus 2 by pi x, sin square x plus cos square x. So this gives simply 2 by pi x. These relations in GATE exams, directly questions comes from this, based on these relations. So relation number 5, ddx of x power n j n x, this is equal to x power n j n minus 1 x. Now recurrence relation number 6 gives ddx of x power minus n j n x, this is equal to minus x power minus n j n plus 1 x. This. Now recurrence relation 7 gives j of n dash x, this is equal to, we can write j of n minus 1 x minus j of n plus 1 into x, this. And also from this we can write x j n dashed x, this is equal to n j n x minus x into j n plus 1 x. Lesson number 8, j n dashed x, this is equal to n by x j n x minus j n plus 1 x. This we can write, and this another form is j n minus 1 x, this is equal to, sorry, j n minus 1 x minus j n plus 1 x, this is equal to, we can write 2 j n dashed x. This, from these relations we can write these relations also. Number 9 is j n dashed x, this is equal to half into j n minus 1 x minus j n plus 1 x. This relation number 10, you can write j n minus 1 x plus j n plus 1 x is equal to 2n by x j n x. This, or you can write x j n plus 1 x plus x j n minus 1 x, this is equal to 2n j n x. This is another form of this relation number 10, and this can be written as 2n j n x equal to, you can write x into j n minus 1 x plus j n plus 1 x. So these 10 recurrence relations are the most important relations from which directly questions comes from in GATE exams and many other exams in which Bessel functions is related in the syllabus. So now these are the recurrence relations, and now we come to the point. So the solution of this differential equation. So the general solution of the differential equation 1, general solution of equation 1, that is x square d2y dx2 plus x dy dx plus x square minus n square into y, this is equal to 0. So in form of Bessel's function, the general solution is 1 y equal to a j n x, where a is constant, plus b j of minus n x, when n is not an integer. And number 2 is y equal to a j n x plus b y n x, where n is an integer. Now this yn is known as Bessel's function of second type. Since Jnx is the Bessel functions of first kind and Ynx are the Bessel functions of second kind. So Ynx equal to Ynx, this is equal to, you can write in terms of Jnx. So Jnx into cos n pi minus j of minus nx, this minus, sorry, j of minus nx by sine n pi. This is known as, where n is not an integer, this. And in case n is an integer, ynx equal to, right, limit nu tends to n j nu x cos nu pi minus j minus nu x by, this is sine nu pi, this, where n equal to integer, this. So the general solution of Bessel differential equation is in terms of Bessel's functions of first kind and Bessel functions of second kind. Now again, and another topic is the generating function for Bessel's differential equations, or Bessel's function you can write also. So we are not going to the proof. So exponential of half into x z minus 1 by z, this is equal to summation over n equal to minus infinity to infinity z power n jn x. This is known as generating functions or Bessel's equation. Now another topic is trigonometric expansion of Bessel's functions. Trigonometric expansions involving Bessel's function. This. Now number one is, these expansions are also important for exams. So number one is cos of x sine phi. This is equal to, you can write in terms of Bessel's function j0 plus 2 cos 2 phi j2 plus 2 cos 4 pi 4 phi j4 plus so on. Number 2 is sine over x sine phi. This is equal to, you can write 2 sine phi j1 plus 2 sine 3 phi j2 plus so on. This. Number 3 is cos of x cos phi. This is equal to, we can write j0 minus 2 cos 2 phi j2 plus 2 cos 4 phi j4 minus, so this is alternating plus minus and so on. Number 4 expansion is sine of x cos phi. This is equal to, you can write 2 cos phi j1 minus 2 cos 3 phi into j3 plus 2 cos 5 phi into j5 minus and so on. So this is also alternating plus minus. Number 5 is cos x. This is equal to j0 plus, sorry, this is minus j2, sorry, this is 2j2 plus 2j4 plus 1. So in summation form you can write it as j0 plus 2 into summation n equal to 1 to infinity minus 1 power n j to n x, this. And the next one is number 6, sin x. So trigonometric series expansion involving Bessel's function. So this is equal to, you can write 2j1 minus 2j3 plus 2j5 alternating plus minus and 2 into odd j. So this can, you can write this is 2 into summation n equal to 0 to infinity and minus 1 power n j to n plus 1 x. We can write this in this. So this, and another one important thing is from exam point of view is orthogonality of Bessel's function. This is another one important topic. Now, so if lambda I and lambda j are roots of j in lambda this a, this is equal to 0, then integration 0 to a x j in lambda I x into j in lambda j x dx, we can write this is equal to 0 if I not equal to j and a square by 2 j n plus 1 square lambda I, this, if I equal to, sorry, equal to j, this. So we can write it as a square by 2 j n plus 1 square lambda I a into delta ij, where delta ij is the delta function, Dirac delta function, which is defined as delta ij equal to 1 if I equal to j and 0 if I not equal to j. So these are the mainly the basic things about Bessel functions. Now we have discussed a problem which comes in GATE exam. This is the previous year exams. So the question is, the Bessel's function j0 alpha k x, this is k equal to 1 to infinity with alpha k denoting kth 0 of j0x from an orthogonal system on closed interval 0 1 with respect to weight function the fourth option are given 1 x square x and double of x. So this is clearly the questions comes from the orthogonal property of Bessel's functions. So it is direct from orthogonal property. So the weight function is from this integration. It is clear that this x is multiplied by these two Bessel functions. So this is the weight function for the Bessel's function. So here clearly the answer is x is the weight function. So now discuss another problem which is comes in GATE exam, GATE 2015. So the question is says that like this: exponential x by 2 t minus 1 by t equal to j0 plus summation n equal to 1 to infinity jn x into t power n plus minus 1 power n by t power n, this for all t greater than 0 and x belongs to R. The value of j0 pi by 3 plus 2 summation n equal to 1 to infinity j2n pi by 3, j2n to pi by 3, this. So how can I solve this problem? This problem comes from the trigonometric expansions from these 6 properties, based on these 6 properties. So the given expansion is this j to j2n. So we apply the series of cos x sin phi series. This is equal to, we write j0x plus 2 cos 2 phi into j2x plus 2 cos 4 phi j4x. Put phi equal to 0 and x equal to pi by 3. Put phi equal to 0 and x equal to pi by 3. We get j0 pi by 3 plus 2 j2 pi by 3, and cos phi means cos 0 means 1, so this plus 2 j4 plus so on, this is equal to x cos phi, and if we put phi equal to 0 then this gives 0, so cos 0 means 1 clearly, which is equal to, write in the summation form, j0 pi by 3 plus 2 common summation n equal to 1 to infinity j to n and pi by 3, this is equal to 1. This is the given question, j0 plus 2 summation j to n pi by 3, which is equal to 1. Therefore the answer of this question is 1. So in this video we are discussed and a small discussion about Bessel functions and the recurrence relation, their properties, one or two problems. So if you like this type of content, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. Thank you friends, see you again in the next video.